Welcome to lecture 20 of financial management, and in this lecture we are going to continue our discussion on capital budgeting techniques. Moving towards the contents, we are going to explore the internal rate of return technique. Remember, we are discussing capital budgeting techniques that are used to identify or help us in finding the profitable projects. And we had previously discussed NPV, payback period, accounting rate of return, and profitability index. And in this video, we are going to explore internal rate of return, which is also called IRR. And there are two methods of finding IRR. One is the trial and error method, and the second one is interpolation. We are going to cover both of these methods. So starting with what IRR is, it is the discount rate at which the present value of cash inflows of a project equals to the present value of cash outflows. I repeat, it is the rate, the value of R. Remember, how do we find the present value? It is future value divided by 1 plus R raised to power n, right? Now, in case of a project, we have cash inflows and cash outflows. We find the present value of cash inflow, we find the present value of cash outflow. Now, at what rate the present value of cash inflows would be equal to the present value of cash outflows? So that R is called internal rate of return. That discount rate is called internal rate of return. So now you can look at the definition: discount rate at which the present value of cash inflows from a project equals to the present value of cash outflows. In other words, we can also define this IRR as the discount rate where NPV is equal to 0. Remember, NPV is equal to what? NPV is present value of cash inflows minus present value of cash outflows. When present value of cash inflows is equal to present value of cash outflows, then NPV would be what? It would be 0. So the discount rate, the value of R at which these two becomes equal, would also mean that it is the value of R at which NPV becomes 0. So we can also define IRR as the discount rate at which NPV is equal to 0. This is the definition that you find in most of the textbooks. Okay. So when do we accept a project on the basis of IRR? A project is accepted if IRR that we find is equal to or is greater than RRR. And what is RRR? It is the required rate of return. Let's say a company's required rate of return is 20%, then we would only accept a project that have an IRR of 21%. So if IRR is greater than required rate of return, then we accept the project. If IRR is less than required rate of return, then we do not accept the project. Or we can say the higher the IRR, the more better, the more profitable the project is. So moving towards an example, let's say there is an investment that would cost $100. It is the cash outflow, initial investment, and has a cash inflow of $60 per year for 2 years. Now, if we find the NPV at different value of R, at different discount rate, let's say we first use the discount rate of 0, you can do it yourself, but you would also get these values. At the discount rate of 0, the NPV would be 20. right? At the discount rate of 5%, the NPV would be 11.5. At 10, the NPV would be 4. At 15, the NPV would be negative 2.5, and so on and so forth. What does this show us? First thing is that as we increase the discount rate, the NPV decreases. So as we increase the discount rate, as we increase the value of R, the NPV would decrease. And you can see that at this level, somewhere between 10% and 15%, the NPV becomes 0 because it is positive here, and it becomes negative at 15%. So somewhere between 10 and 15%, the NPV is 0. That discount rate is our IRR. That discount rate at which NPV turned into 0 is called IRR. By the way, this table where we calculate the NPV at different discount rate is also called NPV profile. So NPV profile is what? It is basically finding the NPV for different discount rates. So it just gives us an idea that what if the discount rate is this, then what would be the NPV if discount rate increases, how the NPV would change. And we can depict this graphically. This is the same example. It shows that the IRR is 13.1%. We are going to calculate it. So if the discount rate is greater than this IRR, then NPV is negative. And if IRR is less than if discount is less than this IRR, then NPV is greater than 0. Right? So this is just the graphical representation. Let's move towards an example and understand how do we calculate IRR. A project has a total upfront cost of 435. This is the initial investment. The cash inflow will be 100 at the end of first year, 200 at the end of second year, 300 at the end of third year. We need to calculate IRR if we require 18% return. Should we take this investment? What is this 18%? It is not R. It is our required rate of return, because it says if we require 18%, right? This is basically our required rate of return, and we are going to find IRR. Then we are going to compare it with this RRR. And if our IRR is greater than 18%, we would accept the project. If it is less than 18%, we would not accept the project. So let's move towards the solution. We have two methods of calculating IRR. First one is the trial and error method. First, we are going to use the trial and error method. In trial and error method, what do? Is we assume some R, some value of R, any value of R. We find the NPV. If NPV turns out to be positive, then we increase the value of R. If NPV is negative, we decrease the value of R. So by doing different trials, what we try to do is we find the value of R where NPV turns out to be 0, and that is our IRR. So that's why we call it trial and error method, because we try different value of R to find the 0 NPV. So we first assume, let's say, it is not mandatory that we would always assume 10% discount rate, but in this case we are going to assume 10%. So assume a 10% discount rate and calculate NPV. We already know how do we calculate NPV. We find the present value of cash inflows, because NPV is present value of cash inflows minus present value of cash outflows. The present value of cash inflows will be, our first cash inflow was 100 divided by 1 plus 0.1. The interest rate we are taking, the R value we are taking is 10%, that is 0.1 raised to power 1. Then we discount the second cash flow and the third cash flow. These are the present values. 480 is the present value of cash inflow. We find the NPV and NPV would be equal to present value of cash inflow minus the present value of cash outflow, which was 435. NPV turns out to be 45. In this case, NPV is positive. That means the value of R that we took is lesser than IRR. We need to increase this value, because once we increase this denominators, the present value of cash inflows, this part, would decrease, and we need to bring it to 435. We need to use a discount rate, a value of R that would make this 480 into 435, and that we would get the NPV of 0, and that discount rate which turns this NPV of 0 would be our IRR. So now when the value is positive, we need to take a higher discount rate. So let's assume we take 20% discount rate, and at this discount rate we find the value of NPV. We again find the present value of cash inflows. Rather than taking 10%, we now take 20%. The rest is similar. We find the present value, and now the present value of cash inflow is 395 minus 435. It gives us a negative NPV. So now that means that 20% is too high of a value. We need to decrease it. So we try different values, different discount values, to come up with a value where this NPV would be 0, and that would be our IRR. So we know that at 10% was positive, at 20% is negative. So the IRR would be somewhere between 10 and 20. So we need to try different values, say 18, 17, 15, 14, 13, to find the IRR. The value, the discount rate at which NPV becomes 0, that would be our IRR. Let's say we take, we assume a 15% discount rate and then again calculate NPV. We would again follow the same procedure. Rather, this time we would take 15% as discount rate. Our present value of cash inflows is 435 and our NPV is 0. Okay, great. So that means this 15% is our IRR. We have found the IRR using trial and error method. Should we accept this project? Remember, our RRR was 18%, right? So when IRR is greater than our required rate of return, we accept the project. When IRR is less than our required rate of return, then we reject the project. In this case, the IRR is 15 and RRR is 18. So in this case, IRR is less than required rate of return, so we reject the project. So let's move to our second method, which is interpolation. IRR can be found using trial and error method and interpolation method. Trial and error method is a difficult one. In previous example, it was sheer by chance that we found the IRR using just 3 different discount rates, but normally it might take 7-8 different tries to come up with the true with the IRR. So it is a cumbersome method, it is a time consuming method. Therefore we have a different method which is called interpolation, and we can use this method to estimate IRR. The formula is IRR is equal to IL, and IL is the lower discount rate. In previous example, the discount rate of 10%, this was the lower discount rate. By lower we mean where NPV was positive. So IL is the discount rate where NPV is positive. IH the higher discount rate. By higher discount rate we mean where NPV is negative. We again have IL. Then we multiply it with NPVL. NPVL is the NPV that we get using this IL discount rate, which is the positive NPV. Then divided by NPVL minus NPVH. NPVL again is the same value we get using IH, or the positive NPV, minus NPVH, which is the negative NPV, or the NPV we get using the IH discount rate. So this is also explained here. So what steps do we follow? First, we find the discount rate at which NPV is positive. It can be any discount rate. So in previous example, NPV was positive at 10%. Then we find the discount rate at which NPV is negative. In previous example, the discount rate at which NPV was negative is 20. Then we use the interpolation formula we just saw in previous slide to find the find IRR. So let's plug the values in this formula. IL, remember the low discount rate, the discount rate at which NPV was positive. So in our case, NPV was positive at 10%. So it is 0.10 plus IH, the higher discount rate, or the discount rate at which NPV was negative. So by higher, we do not mean any value which is higher than 10%. It should specifically be the value at which NPV is negative. So we take one discount rate at which NPV is positive and one discount rate at which NPV is negative. So we need to find these values, right? Okay. Then again, IL into NPV L, which is the NPV that we got at 10% discount rate. You can go back where we found the NPV at 10%. You would find that it was plus 45 divided by NPVL, again 45, minus the NPVH, which was minus 40. Remember, at 20% discounted, we got the NPV, negative NPV of minus 40. We simplify it and we get a value of 0.15 or 15%. This is the exactly same value that we got using the trial and error method. So either you use trial and error method or you use interpolation. They both are same. They both would give you exactly same answer. So again, the decision rule would be also be same. We reject the project where IRR is less than required rate of return. In this case, IRR is 15%, which is less than our required rate of return of 18%. So we reject this project.